Don't just start working on this problem as soon as you get it, observe it first. This calculation is so complicated with both multiplication and addition. Many students start calculating from left to right, one number at a time, and after a long time still can't get the correct answer. Today, Director Yu will teach everyone a trick. By finding identical numbers, we can easily solve similar problems. What does it mean to find identical numbers? Take a look at whether the denominator and the numerator above it have any identical parts. For example, here, see the bottom is 3 times 5 times 7, and the top is 2 times 3 times 5. I notice that both the numerator and denominator have 3 times 5, so I circle them. For the complicated part, I'll just use a letter to represent it. Let's call it A. As for whether we can calculate A later, we'll talk about that in a bit. Actually, it can be easily cancelled out. Let's first substitute the other parts as well. For example, if we look further, here we have 12 times 20 times 28, and above it's 8 times 12 times 20. We found the identical parts, right? Here, 12 times 20, 12 times 20. The complicated part I can represent with a letter, but to distinguish it from the previous one, I'll call this one B. So this is B. All right, moving on. Have you found the identical parts? This is 15 times 25 times 35, and above, it's 10 times 15 times 25. Here, you can circle it, right? Right, to distinguish it from the previous two parts, let's use the letter C to represent this one. Let's organize the whole equation and see what it becomes. On top, it's 2a plus. This is 8b. All right, what is this? This is 10c, which corresponds to the bottom part, and this is 7a. And this should be 28 billion. All right, and here, this is 35 degrees Celsius. Take a look at the numerator and denominator. I noticed that on the top, whether it's A, B, or C, the numbers in front of them are all multiples of what? Aren't they all multiples of 2? So in a moment, I can factor out a 2. Then what can I factor out from the bottom? Can I factor out a 7? Here, and here. Aren't all of these multiples of 7? All right, next, we'll factor out the common factors. Inside the parentheses, it should be A plus 4B plus 5C. That's the numerator on top. What about the denominator below? After factoring out 7, it should be A, and over here it's 4B. After factoring out 7 from this part, what do we have? 5 degrees Celsius? You see it now, right? From the very beginning, the teacher told everyone that in the end, all of these can be cancelled out because these two parts are exactly the same. So isn't the final answer to this problem just 2 over 7? All right, that's the end of this problem. I suggest you give it a like and save it after watching and review it a few more times. Otherwise, if you want to use such a useful method again, you might not be able to find it.